Hey everybody, this is Larry. This is day 22 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, and let me know what you think about today's problem. And there's also a weekly problem, is what I just noticed. Is that day of the week or whatever. But yeah, hope everyone's doing okay. Yeah, life's a little bit odd these days, but we'll see. Hope everyone's doing okay. And take care of yourself and take care of people who you care about. Anyway, let's take a look at today's problem. We have 1765 map of highest peak. Okay, so you're given is water, okay, a matrix, all times C or by C. 0 is land, 1 is water, okay. You must assign each cell a height such that it has the height of each cell is non-negative, okay. If the cell is water is 0, and then the height is at most 1, and you want to maximize the height. Okay. I mean, this is just binary search, right? Oh, sorry. Wow. No. I mean, I had BFS in my head, and then I don't know. My first search. I don't know. Right? The key thing to note is that when you want to maximize, in this particular case, you just have to ask yourself, actually, oh yeah, no, yeah. Actually, let me double check this. I need 2 adjacent cell. Actually, maybe I'm wrong on this one. I mean, my initial idea was going to be something like that, but I'm trying to think whether there is a counter case. No, I think buffer search is right. I think I was just trying to think whether I'm being weird, where there's a case where you have, I don't know. I think let me just collect my thought for a second. But I thought maybe there's a case where you have a 2 coming in, and then maybe on the other side there's a 5, and then this number would not necessarily be a 3, and it can be a 4. So you have some weird contradiction here. And I was like, oh, what does this mean? But then I was like, oh no, you're just being silly, Larry, because by definition, if you have this to be the case, and if you do a breadth search, then this would be limited by, I don't know, 2 or 3, because that's just where you're on the breadth search, and so this would just never happen, right? Anyway, the reason why, let's step back a second. I know I'm going a little bit, I just want to give y'all like my thought process as it comes up to me, especially when I encounter something that I was like, oh, this is a little bit different, maybe. Turns out it's not, but I thought like, oh wait, let me double check my math before I finish saying it. So anyway, okay, right. So we have okay, yeah. So it's breadth first search, right? But part of that is just shortest paths, because in a way, because we're gonna maximize things, we want to get them to be greedy, right? And greedy in the way that shortest path problems are. That they build off each other, which is also, by the way, there are assumptions with shortest path problems, which is why, and greedy, which is why you cannot have negative edges or negative cycles depending on the algorithm, because it makes certain assumptions that allow greedy to work. That's another story for another time, but that's just, it is greedy in that sense, right? Yeah, and then here, now, the way you can formulate this as a shortest path problem is just asking for each cell, okay, what is the highest that it can be? Well, the highest it can be is just 1 away from all 4 of its neighbors, right? And then, well, there are 2 ways that can happen. One is if it is it has neighbors that are shorter, and then it has neighbors that are higher, right? And of course, if we kind of do it in a systematic way, then we will start with the neighbors that are smaller, and then the neighbors that are higher you don't deal with, because they in a way, if you're looking at a cell and you're that cell, you're like, oh, I don't care about you, you go after me, whatever, in an inductive kind of way. Anyway, that's really the thought process about this problem. Feel free to, I think one thing that I haven't said a lot lately is that I think, the reason why I do these things live and every week, or every day even though I probably have this video. You might have Googled it or whatever, right? Like, it's not a ridiculous problem. I probably have a video out already. Is because, well, two things. One is that so we can do them together. Sometimes you research for it, and people sometimes leave comments on my older video and be like, "Oh, why don't you try this?" I'm like, I don't know. I don't remember who I was a week ago, let alone 2 years ago or whatever. I don't remember my thought process that much. These problems honestly do not mean anything to me. I try not to memorize them as much as I can because I don't have enough brain cells to memorize stuff like this. But anyway, my point there is just that I'm here to hopefully we'll solve the problems together. My good days, my bad days, all the days, for the most part. And then the other thing is that I haven't talked about this recently, though I bring it up from time to time. So if you have a newer viewer or newer studier, there are two parts to every problem, right? There's the algorithm part, and then there's the implementation part. Sometimes they go together. Sometimes the algo part is harder. Sometimes the implementation part is harder. But on an interview, or competitive programming, really, I suppose, you have to do both, right? It's not good enough to just be okay at one. And it's okay to practice just one, though, for your practice, right? That means you could try to practice the algorithm and maybe skip on the implementation, though that's a little bit awkward. But the other way is probably a little bit easier is, if you now know the ideas and the algorithm, still try to implement it before looking at my solution. So that's what I would say. And I mean, even I need some practice because, as you can see, I keep on making silly mistakes the last week or so. But it is what it is. In any case, but even as I say that, right? Like, and maybe this sounds a little arrogant, maybe I don't know, a little cocky, but I could be really bad at a lot of things. But the problem solving, that's the part that you learn, and that's the muscle that you exercise over time. That's the part that doesn't go away. It doesn't matter what your tooling is. It doesn't matter if you're using Python or C or Java. And I've done competitive programming in Java, in C, in C#, in Python, I suppose, if you count Leetcode. What else have I done? I feel like I've done one more. But either way, maybe that's enough. And C++ if you want to separate that out. But my point is that, like, the language doesn't matter, right? Like, I mean, it matters to some degree, but that's not, that's not a reason why you're not getting better. So, I don't know. Within reason. I mean, there are some caveats because I think some contests, for example, if that's your parameter, some contests do have, they're just not sensitive to certain languages, and that may have, But anyway, that's a whole meta conversation that I'm not going to have, even though I did bring it up. Anyway, let's actually implement the solution, right? So here, as I said, it's going to be breadth first search. You want to start through the cell. So it's a multi-source shortest path. And you just kind of go around and dance. And it's just the distance from the water is really as high as it can get, right? So yeah. Yeah. Okay. So what am I doing? Yeah. And maybe we'll have nope. Doing that. Yeah, fine. I mean, it doesn't really matter because it's breadth first search, so it doesn't really matter what your initial value is, as long as, well, it's not a value, and as long as you just enqueue once, right? Maybe we have an enqueue function just to help us out. What do we have? XY, is that it? And maybe D for distance, right? So enter XY is equal to D, q.append D, right? Oops. And then now, yeah, and then we kick it off with the multi-source so what is it? Is which one's the water, 1 or 0? Huh. Right. Alright, and then now there you go. XY is equal to q.pop left, right? And that's it, right? You have to set up the direction, up, down, left, right, not in that order. It is, I don't usually, I just do whatever feels right in the moment, which could mean anything really. But But this I usually write mostly the same way, at least in Python. In C++, I write it a different way, or C like language anyway, not just C++. I'm gonna keep it in bounds. And we want to make it, what was it? Yeah, answer. Oops. Then we have in Q, and X and Y, and that's it. Then we just return answer, right? Oh, whoops. Yeah, and that's hopefully should be it. I messed up, didn't I? Oh no, I had it on NQ. Okay, I forgot. Sometimes I forget things because the thing is that I have been like probably realistically and not even exaggerating by much, BFS like 1,000, 2,000, something like that time. So sometimes I just forget certain things because I'm typing so fast because I'm not thinking. That's kind of the mistake, is that like I'm like it's on almost autopilot. I wouldn't say pattern, because in my mind, like you see me type it out, but it's just that like because I'm typing and I'm not thinking, or we examine every line, sometimes I forget things, or like sometimes I forget this part. I'm like, oh, why are we queuing too much? It's time limited. Anyway, silly things do happen like that. But yeah, what's the complexity here, right? Well, it's just gonna be linear time, linear space, and that's it. I mean, that's regular breadth search stuff, right? It's v plus e, v is n, e is 4 times n for number of edges, and keeping in mind that n is equal to r times c. So when I say linear, it is linear in the size of the input. I think some people get that confused a lot because they use n for one of the sides for a grid, and as a result they say it's n squared, but that's not. I mean, that's quadratic, but not. The algorithm isn't dramatic. It is dramatic, but it's not quadratic, right? So that's basically, yeah. That is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.